Okay, so in the last lecture, I try to uh, like up to 100 page. I try to explain like what is this and that. So basically, there are something like uh, last class. What I remember that I learned like or teach like at the same time and learn and teach also. That is basically the mm, generator, parity generator. So the parity generator and parity checker. So I learned in the last lecture. Now I started to uh, learning or teaching at the same time. That is in bit even parity generator. So that's I already know. So magnitude comparator here is in bit even parity generator, that is P equal to A XOR B XOR C. So here is, so basically for even parity generator, so I want to detect how many odd number of one is there. So that is my even parity generator. So suppose in a 4 bit like something 0 1 1 1. So this is my basically even parity generator. So if we take XOR of everything, like here is my A, B, C, D. So if I do XOR of this, like A XOR B, XOR C, XOR D, so I got the P like parity generator, even parity generator equal to 1. And if odd parity, for odd parity, I take the to the XOR again. And if it is 0, like in 0, so that time in bit even parity checker, so like okay, so the bar basically, so even parity, if there is even parity means like odd parity, sorry, odd parity generator, so there are even number of one. So suppose this, so if I take XOR of everything, then I got 0, and XOR bar, so we take XOR bar. So these type of things we do here. And if 0, then 1. So you can see here that we take the XOR. Okay. So and n bit even parity checker. So for checker, we just like here is like 4 bit, something like this. And okay, so in even parity checker, so we just focus on the zeros, how many zeros are there. So if that is even zeros, then my parity checker is even. So how I do this, so in that case, n parity even, in n bit even parity checker, so if suppose my even number of zeros are there, so even number of zeros and p, so it gives me like here it gives me the even parity case for 0, just like that. And for n bit odd parity checker, so in odd parity checker, so is there are even number of odd number of zeros are present, so that gives me the 1. Okay, so here is it is 1 because it's odd parity. Maybe you can't feel that my voice is or energy is down, but I have little bit like uh, little bit headache and also fever. So hope you will not minded it. Maybe sometimes like my voice is changing or energy is down, but I hope I try to give my best. So magnitude comparator, I don't know what the problem is this. Okay, just a second. Just a second. Okay. I think previously something is not recorded, but now it's recorded. So basically I am not doing like very big concept in here. I'll try to just the revisit the previous lecture what I told, and only that. And 1 bit magnitude comparator. So in comparator, so we want to make a comparator. So how to make comparator? For comparator, for 1 bit comparator, so you need to check the bit. suppose we have a 1 bit comparator, so 0 and other bit would be if 1, then you need to compare between 0 and 1, like this is your a bit and this is your b. Okay. So if we compare a and b, so which will high? So obviously b is my a is less than b, so the output a is less than b, a is greater than b, and a equal to b. So in this case my output is a less than b, so this is 1, this is my 1, and rest of the bit are rest of the output giving me 0. Okay. And if it is 1, uh, if suppose my this is 1, this is 1 and this is 0, then my uh, so this is 0 and my a greater than b, so this is my 1. Okay. And the other cases such as like if here also 0, here also 0, then everything is 0 except a equal to b, here 1. And if both are 1, then here everything is 0 except a equal to b. So how to do comparator? So actually this is my 2-bit comparator, like 1-bit comparator. Here a equal to 1 bit and b equal to 1 bit. If suppose I need to make a 2-bit comparator, then how can I do? So I make a truth table and go through this. Okay, let's me make a truth table for 2-bit comparator. Okay. For 2-bit comparator, I take A1, A naught, and B1, B naught. Okay. So there are total 16 possible way like my output can be. So here is first output should be A greater than B, second output A less than B, and third output A equal to B. Okay. If I put like everything is 0, like my A1 A not be 0 and B1 B not be 0, then what is my output? So 0 0, both are 0 0, so then output is here 1. Next I put 0 0 0 1, then what is my output? So here B1 and B not like 0 and 1, so it's decimal, in decimal it is 1, and A1 A not its decimal is 0 0, so decimal in decimal it's 0. So obviously my A less than B, so here is 1. So we follow that's the way. So again here 1. Sorry, 0 1 0 0. So if I put 0 1 0 0, obviously in this case this is 1, this is 1, and this is 0 in decimal. So obviously A greater than B. So here 1, and rest of the part is 0. So 0 1 0 1. So obviously A equal to B. So here is 1, 0 1 1 0. So obviously this is my 1 because A less than B. 0 1 1 1. So it is a 1. Now it's change 1 0 0 0. So 1 0 0 0. So my A greater than B. So here is A greater than B. 1 0 0 1. Again A greater than B. 1 0 1 0. So here it is 1 because both are equal. Sorry, this is my A less than B. So this is not B1. Okay. This is my 1. 1 0 1 1. So basically A greater than B. So obviously A less than B. Here is my 1 and 1 1 0 0. 1 1 0 0. So what is my output? Output is A greater than B, obviously. 1 1 0 1. So my output here also 1 1 0. So again 1 and 1 1 1 1. So here A equal to B. So now check the output. Like I need to make a circuit of A greater than B, A less than B, and A equal to B. So how to make the circuit? So just while is 1, just go through the K map, and you need to just like this way. Like this. You can make A greater than B. So your A1 A0 is here, B1 B0 is here. So 0 0 0 1 1 1 1 0 0 0 0 1 1 1 1 0. So according to the greater than B output, so 0 1 double 0. So 0 1 double 0. This is my output, and also 1 1 0 0 1 1 0 1 and 1 1 1 0 and 1 0 0 0 1 0 0 1. So this is my output, I think. Now make the K map. So here I take this, here I take this, here I take this, and here I take another one. So this is my K map for A greater than B. Let's check A greater than B. Okay, he does not make any circuit, I think. I think a 2-bit magnitude comparator. So A greater than B. I think he was also telling that how to make check 0 1 0 0. So obviously 0 1 0 0 is A greater than B, A equal to B, and A less than B. So in bit comparator, 2 n bit at input to the 2 n total combination. That's I already know, and that's I already told. And what is the thought? So A greater than B. So without K map he solved it. So you can go through the K map and you find the same answer. Now making 2-bit comparator from 1-bit comparator. So how to make a 2-bit comparator from 1-bit comparator? Okay, so A1 B1, he takes the input from 1-bit MC, and here is 1-bit MC. Okay, if it is equal, like if A1 greater than B1, so that's going to here. Obviously we got the output of G, that is G1 plus E1 and L1. E1 and G0. Okay, so that is what A1 greater than B1, A1 equal to B1. A1 equal to B1, then it's check what? So A1 equal to B1 here, and it's check here and goes to my A not B not. So equal to is here again. If both are equal, then it is equal. If one is equal, other is not equal, like here A not greater than B not, then my output should be like this. And if A1 equal to B1, but other is like A not less than B not, so my output should be here also we can make, but he does not make the circuit. Okay, I will make the circuit in here. How to make 2-bit comparator by using 1-bit? So here I take 1-bit comparator. That is my A1 and this is my B1, and here is my 3 output. Okay, just a little bit far away we can write. So this is 1, this is 1, and this is 1. And here also my 1-bit comparator, that is A0, and this is my B0. Now I am checking like 3 output. So 3 output, how to check? So I feel that my A1 greater than B1 here, and this is my A2, Okay, just a second. This is my a1 equal to b1, and this is my a1 less than b1. Same as here, a naught greater than b naught, a naught equal to b naught, and a naught less than b naught. Okay, okay. Now, if my a1 greater than b1, so obviously my output is like here. I take OR gate, and here obviously my the all bit a greater than b. And if suppose my a1 equal to b1, but what happened that my a not greater than b1, so that also be one possible way. So here we can make a greater than b, and other possible, suppose my a not equal to b not. So obviously if my a not is b not, don't care if my msb is already greater than. If my a not equal to b not and my a1 equal to b1, so I take another circuit from here. If my both AND gate, so then my output should be a equal to b, otherwise not. And if my output, so I go through green line, if both are less, if a1 is b1, obviously my output is a less than b. And if my a naught is b naught, but a naught less than b naught, but a1 equal to b1, so like this, and here like this, then my output also a not a less than b. So my msb is same, but if my lsb is less, then obviously a less than b. Then if both are equal, a1 equal to b1 and a not equal to b0, then a equal to b. If msb my already is greater than, then obviously it's a greater than b. Same as if my here we take the input like a1 is b1 and we check the a not is greater than b not or not. So then we add, just did this way. And if suppose like we need to make a 4-bit comparator by using 2-bit comparator, so how we can do it? So basically, uh, like 4-bit comparator, right? So here is we take 2-bit comparator, and here is again 2-bit comparator. So 2-bit comparator, there are 4 input, 2, 3, 4, and again here is 4 input. So if I make a 4-bit comparator, so there are 4 4, so something like that. But how to make 4-bit comparator? Okay, here is my a1, b1, a naught, b naught. Okay, I'll just not this way. Here is my a3, a naught, b3, a2, b2, and here is my a, a1, b1, a naught, b naught. Okay, so if I, so 3 possible case are possible. One is my, like suppose I name it is a dash greater than b dash, a dash equal to b dash, a dash less than b dash. Here I name a dash, like if I put the name like this way, Here I take small. Okay, a dash greater than small b dash, a dash equal to b dash, and a dash. Here I take to a dash less than b dash. So the same way I can do. Okay, here I take the a dash greater than b. So obviously it's giving me the output of a greater than b. And other way, if it is like this, and here my a dash is like this, then my output goes to here, and it gives me also a greater than b. And if my output, like I want to be, not I want to be, so I need to, I need the answer of a equal to b. So here I equal to this, and yeah, this is I do the or and. I don't understood. Yeah, both are. If in both case like a dash b dash, then my given one, so it is okay. A equal to b. And if it is like something like that, if my output is what, my output, so if a dash is already, like your msb are already less than b dash, so then mm, it's giving me output of a less than b. And if my a dash less than b dash, and also we need to check the my equivalent here from here, from here. If I do both the and, yes, if it is a equal to b dash, and my here it is, so obviously it goes to here. So that's the way we can make also 4-bit comparator. I hope now the concept is understandable for everyone. Okay, so 3-bit MC from 1-bit MC. Okay, you can do the 3-bit comparator. You can 3-bit MC from 2-bit MC and 1-bit MC. So you can do the anything. Now it is multiplexer. Okay, so multiplexer full form is like what is multiplexer? So many to one selector or switch takes multiple input, provides single output based on the select line. Okay, so here is select line. So select line, and here it is maximum. Suppose you take n select line, and here is you can maximum 2 to the power n input you can give. Okay, more than 2 to the power n, it's not possible by choosing n select line. So your output, you can show the output properly if you choose more than 2 to the power n inputs. So at once time, at single time, it gives only one output by based on the select line and input. So 2 cross 1 marks. So there is 2 cross 1 marks. So this is my, suppose if my select line is 0. If it is 0, then it is selected I naught. If my select line is 1, then it's choose I1. So I1 choose and it goes to Y, something like that. So how to make this circuit? How to make 2 cross 1 circuit? Okay. Here is my 2 cross 1 marks. So according to the based on the select line, we need to choose like what. So here is select line. So select line. So I think S bar and S. Okay. S bar means equal to its 0 complement 1. So 1. So that, okay. I hope you understood. So 0 complement, that is 1. And S is equal to 1. So when is my bit is S bar? Then here is my I naught. Choose I naught, and here is my ion. Here is my output. Output. So how to make output? Suppose output is my Y. So my output is Y. So how to make output? So basically your S bar and I naught plus S I1. So how to make and get two input? Sorry, here is I take like inverter. Here is my select line. Here is my another AND gate. Here is A and B. Here is sorry A and B, not A not B not. So S bar. Here is my I naught. Here is my ion. So this is my output Y. The circuit is this for 2 cross 1 marks. Here you can see. Just wait for saving the PDF. Here is not get. So whatever the S is here, S bar is here. If suppose your S bar is S is 0. So 0 then it goes to 1 here. So 1 and I naught is I naught. I naught into 1. So that goes to I naught here and that goes to the output here like way. If suppose my S equal to at that time S equal to 0, so it gives me the output of 0. If S is equal to 1, that time only I1 you can multiply and with the I1 and it here output 1 and thus the gives way I1. And here is your 4 cross 1 marks. 4 cross 1 marks is obviously there are two select line. If two select line is there, so it total are n total 4. So here I naught I1 I2 I3. So obviously and here it is your 3 cross 8 cross 1 marks basically. So three select line is present. Find the multiplexer of mean terms of y. Okay, so mean terms of y. So your output y in terms of a for function of ABC. Let's how I can do this. Let's check. Here I think I can do. I don't need to go anywhere. Suppose your B bar and C bar. Then what is your input? That is A. And if your B bar and C bar, if suppose it's B bar and C, then your output is like plus B C bar, that is A bar, and here is ABC. So this term is 0. So obviously this is 4, this is 2, and this is my 7. And why it is like 3? How we can get 3? I1 is 0, then okay. This is not A actually, this is your 1. Guy forget. So obviously if it is 1, so ABC plus A bar BC. So obviously 3 will also come. This is my output. So you can see here. So find the mean term of Y. This is my mean term. Okay, yeah. This is my Y equal to B bar C bar A B bar C bar 0. So this is my mean term and find the mean term of Y. So obviously you can do again BC. So BC B bar C bar. So you can write A bar and A also. So it is 0 4 is here, and BC so A bar and A right you can here, so 3 and 7 3 0 3 4 7 0 3 4 7. Your output should be, what is my output? So 0, just a second here, 0 3 4 7. Yeah, but this is the minimize term, I think. 0 3 4 7. Okay, go through KMF. Yeah, obviously it's like, but 0 3 4 7 should not be your output. Your output should be a little bit changed. So what the fault mistake I did? I don't know what is the problem. All the variable used as select one. Yeah, but line is you selected this, but the actually your input look like this, like 0 0 4 0 3 0 4 3 7. So minimize expression of input. Okay. Suppose you are giving the 0. 0 is where? So BC. So I assume that your B C both are as 1 1. So BC is 1 where? So if it is 1, then it's selected A, and I hope the A is the MSB. I hope A is MSB. So A B C plus 1 your B bar C bar. So it select B bar C bar. That times it select 1. So A bar, or you put A. When it's B bar C, when it puts A bar or A, and when it's like B C bar, B C bar, then it's is like A bar. So it's 6 1 2 1 2 3 4 5 6. Sorry, 2 7 7 is for the total 7. So A bar B bar C bar is also coming, but which term is not coming? That is my BC A bar. I think yes, the BC A bar. So my third term is missing. Third term will not come. If my third term is not come, then obviously my 0 1 1 only one term. So obviously A plus B bar plus C bar. You can write it this way, like in MSB form. So minimize expression of output. So here is my input is 0 S1, that is 0 and 1 is 0 S1. So I not I1 I2 I3. So B bar 1 0. Then what is my output? So minimize expression of output. S1. So if my S1 is depends on A, okay, and S0 is already 0. So if my S0 is 0, S0 is already 0 and S1 is A, okay, then two combination I think possible, that is A bar 0 and A and 0. So 0 0, both are 0 0 or 1 0. So 0 0 means B. So your A bar B, or either that is A 1. This is only possible two things. So that is A plus B, like OR gate. And another way you also make OR gate. That is like suppose this is your input, um, select lines. So how we can make OR gate? Two input, that's A B. So in both are 0 0. So here 0 0 and rest of the bit connected to 1. So then my output is behave is like a OR gate. So here is the another problem of marks, and mean terms y should be combinational circuit with enable bits. Here is again enable bits are present, active high enable input output, enable 1. So combinational circuit with enable bits. So active high enable. So input enable output. So high is my enable 1. Then my combinational circuit will work. If my enable is 0, then combinational circuit will not work. Active low enable. So in active low enable, if my enable is 0, then my circuit will work. If my enable bar is 1, then my circuit will not work. And this is the combination in gate exam also, like these kind of things they can ask basically. So here is another, that is A is my input and 1BC is my, like A is select line and 1B is my input and enable is C. So when enable is 1, so if my C is 1, then my circuit will work. But when C bar is like C is 0 or like it's C bar, then my circuit will not work. So marks as a universal gate. So how to marks as a universal gate for AND gate, NOT gate. So all the gates how I make by marks. Okay, for marks, just a second. So here is my marks. So how to make universal gate? Okay, so start with NOT gate. If my A, so here I take A. Here is my two input, that is I naught I1, and here is my output. So how to not? So here is my 1. So 1 into A bar, that is my A bar. This is not gate. And if I want to make AND gate, how to make AND gate? So I need two input A and B as a select line and also the gate input. I can say that, and when it is 1, that is 1. like your I3 or rest of the bit I2, I not I1 and I2. This gives me should be 0. So here is I connected with ground. So this gives me like this is my AND gate. Output is Y equal to A, B and 1. So 1, this is behave as AND gate. And now if I want to make OR gate by using marks, then how do I do it? Okay, here is my select line A and B again, and 0. Here is my I0. So I0 should be grounded like 0 here, and everything except I0, everything should be 1. Here is 1 input, so my output is behave as Y equal to A, sorry, just like A or B. So this is my OR gate. And XOR gate, how to make XOR gate? So in XOR gate, there are two input like A and B. So that is also select line of marks. And here is my total 4 input, that is I0, I1, I2, I3. So in XOR gate, what is the output? That is A XOR B. Basically, A XOR B is nothing but A bar B plus A B bar. So basically, A bar B. So in case of A bar B, we need to select I1 and I2. So here is only I give 1, and here I not also 0 and I3 also 0. So this is my Y, that is A XOR B. So this is my XOR gate by using marks. And another is XNOR gate. So for XNOR gate, how I make two input AB. So XNOR gate, that is AB, AB or A bar B bar. So this is my XOR gate. So how to make XOR gate? So here is my here I take I naught, I1, I2 and I3. So if my both are 0 0 like A and A bar B bar, so here I naught should be 1 and I3 should be 1, and I1 I2 my grounded, I got 0. So this is my Y, that is A XOR B. So this is the basic gate by using multiplexer. And buffer, for buffer case, buffer I am not discussed. So here you can see the buffer and gate AB. So you can also like one, that's the way you can make OR gate. Okay, OR gate basically A bar B got here, and A, so A means AB bar AB. So you can make NOR gate, NAND gate. Okay, NOR gate and NAND gate I need to make. Okay, NOR gate. So NOR gate output is A or B and whole bar, that is I want. So if we write this way, that A bar into B bar, so how to make A bar and B bar? So something like that, that AB is here, so only at the I naught I give the 1, and rest of the all are is my ground or 0. So this is my A bar B bar. So this is my NOR gate. And if I want to make NAND gate, how to make NAND gate? So first we need to know that what is the output of NAND gate. So that is A B whole bar. So how it like if we apply De Morgan's law, so it would be A bar or B bar. So these we want to by using marks. So I always use like in this uh, like how I draw, I use by using 2 cross 1 multiplexer, sorry, 4 cross 1 multiplexer. So I need output. So if my A bar, A bar and B bar, so how I can make? Okay, let me check. So here's the output A bar, B, A bar, B bar, and here it would be A, A bar, B bar, that already done, and A. beaver. So in this case output I need this. So obviously ever beaver. Okay. Okay. This is my 1 and it is my 0. So this is my I0, I1, I2 and I3 and this is my Y. So this thing I want. So A bar, A bar B. So A bar B, for A bar B I choose this. For A bar B bar I choose this. For A B bar I choose I2. So this is my NAND gate. Next NOT gate I already told. Here you can see how to make the gate, basic gates. And here you can see the, you can also like some questions are delay in marks. Oh, how to provide delay in mask. Okay, if suppose my V naught is 0, if it is 0 then it's choose I naught and I naught is my 1, so my output is 1. So if my input is 1, input is 0, then my output is 1, so it's like 1 goes to here. And now if my goes to 1, so after some delay it's choose 0 again and 0 goes to here, so 0 goes to here. And after some delay, that's the 1 microsecond delay of this marks, and this 0 again goes to here and this 0 gives select the 1 and gives me the output like this way. So it's a NOT gate, basically the delay in marks, basically it's NOT gate he want to make. And this is also a stable multivibrator or ring oscillator, dual wave generator, pulse wave generator is it's also called. Or you can say that by this way we can make also clock. Clock is also possible. So we take three inverter here, buffer, inverter, buffer, and find the frequency of oscillation at output. Okay. So my buffer delay should be needed. So here 5 nanosecond, here is 7 nanosecond, 7 nanosecond, and here is 8 nanosecond. So 5, 7, 12, so 20 nanosecond. That is my after 20 nanosecond. So my this output come. This goes to this, and if we check like suppose this is my 0 initially, this 0 goes to here after 5 nanosecond, and this 5 nanosecond after delay of this. So if it is 0, so it's here 0 and this 0 choose 1 here, so total 12 nanosecond is already done. And this one goes to here, and here it is y bar. So if it is y bar, so 1 y bar equal to y bar equal to 1. If y bar 1, then it is 1, then it's choose this, and this 0 goes to here, so it's 20 nanosecond time, and this 20 nanosecond again my output. So something like that. Here is my if output, then it takes 20 nanosecond for positive cycle, positive period, and 20 nanosecond for negative period. So total is 40 nanosecond. If it is 40 nanosecond, then my frequency is 1 by 40 nanosecond. So that is basically 1000 means 40, so it's kilo and mega, so 25 megahertz, my answer. So comment of y, here is s equal to 1, 5 nanosecond delay. If it is 5 nanosecond, yeah, this is the type of like how to make a different of stable multivibrator with generator. This is my bistable multivibrator how to make. So this is basically just used as a buffer, something like that. No oscillation. If all the inputs peak URST are applied simultaneously and held the constant, the maximum propagation delay of the circuit is. Okay, so here is 2 nanosecond, 4 nanosecond, 2 nanosecond, and so that the propagation delay. So if my T naught equal to 0, so here is also 0 and here is also 0. If 0 0, then it will be selected, and if 0 0, then it's not care here, so it's selected. So 2 nanosecond, and what is the max delay? Max delay is not there, I think, or there. So the propagation delays of the XOR gate, AND gate, and multiplexer in the circuit for 2 and 1 nanosecond. So max is 1, but 1 plus 2, that is 3 nanoseconds, so it's not possible. Uh, like we should do it for other checks. So here is my 1, then this will be correct. Here is my 1, so this will not do. So the hit is correct. So 2 nanosecond and 2 nanosecond, 4 nanosecond, 1 nanosecond, and 1 nanosecond, that is 6 nanosecond. So my answer is 6 nanosecond. And same question, that is my t equal to 0 delays 5 nanosecond and t equal to 1. So this is very simple problem. Like if your t is 1 here, so here is 0 after 1 nanosecond, something like that. So you can choose, mm, solve this kind of problem easily. Implementing lower level marks from higher level marks. So that is your 4 cross 1 marks. How to implement this 2 cross 1 marks? Okay, let's try. So here is your 4 cross 1 marks. You want to implement. So here is 4 input and 2 select line, and here is 1. So that is my 4 cross 1. But how you can implement this 4 cross 1 marks by 2 cross 1 marks? So this is my 2 input, 1 select line, 1 in. Okay. So if I like 4 input, so here is my 2 input. So 2 marks is here. Okay, 1 select line. So my if my select line is this, suppose my select line is S naught, I am checking. So I don't know the what is S naught or S1. So my select line is one is S naught, one is S1. So my input is, I check I naught, I1, I2, and I3. Now here is two output. So I go through 1 marks, that is my S1. So if I check here, so this is my 0 1, this is my 0 1, this is my 0 1. So if I put both S1 also 0 and S not equal to 0 also. So S1 equal to 0, so it select this line. Okay. And S1 is not also 0, so it's 0. So it's perfect. Actually S1 yeah. So 0 0, it goes to the output I not. If it is S1 is 1 and S not is 0, then I need to output of I2. So let's check. So I1 is here, so it select this line, and 0 is here. 0 means this, so I2 is perfect. So if my output is S1 is equal to 1, S0 equal to 0, so it should give me output I2. If both are 1, so here, so this select line will be selected, and if it's not equal to 1 also, so this will be selected. So my output is 1 on I3. So my circuit is perfect. So that's how we can solve. Suppose we need to make a like huge amount of like 1024 cross 1 multiplexer by 2. Then how we can 2 cross 1 multiplexer? How we can make? So simple, 1024 by divided by 2. Total is like 5 uh, 524. That is 512, I think. Yes. And this 512 by 2, that is 256. This 256 by 2, that is 128. This 128 by 2, that is 64. And this 64 by 2, basically 32. 32 by 2, that is 16, then 8, then 4, then 2, then 1. So if you add this 16, 8, 4, 2, 1, 32, 64, 122, 256 and 512, then you got the answer, that is 1023. If suppose any number like 1000, like it's called 2048, you can 2048 cross 1 multiplexer by 2 cross 1. So just if it is 2, then just minus 1, like 2047, 2 cross 1 multiplexer needed. If it is 4, then 2048 by divide by 4, until or unless it's below to the 4 or 1, then we can, like, the maximum number get, that should be. In any case, mm, suppose like what I say, 1632, 8 cross 4, so by 4. Okay, suppose I need to make 8 cross 1 multiplexer by 4 cross 1. Then how to do? So in 8 cross 1, so we first take 2 multiplexer, that is 4 cross 1, 4 cross 1. And what's the output? In output we get like 2 output. So how to select 2 output by multiplexer? So that totally like depends on the circuit how to manipulate. So basically that's the way you can make 4 cross. So here is 2 select line, here is 2 select line. But basically one select line is never occurred, like never provides 1. So we just put the like other 2 input into the ground, and we take only the 2 input from the circuit. So here is 2 cross 1 1 multiplexer, and you need to make 8 cross 1 multiplexer by 2 cross 1. So you can see here, and the circuit is here and everything 2 cross 1. So now we are here implementing logic. Okay, this is the now implementing logical expression using marks. So no number of variable in boolean expression is equal to the n equal to s into 1 number of available select line solved by min terms. Input of the max will be either 0 or 1, and number of variable in boolean expression is more than the number of available select line. Make implementation table. Okay, let's see what is this. So if equal to a bar using 2 cross 1 multiplexer, that we already did. AB using, so AND gate, basically OR gate is here 2 cross 1. I already did the same things, like you need to put a AB BC plus CA using multiplexer. So obviously we can make through K-map also. Okay, so I can solve one, like how to do this 3 5 6 7. Okay, 3 5 6 7. Let's check by ABC. So what you did? So first write ABC, AB, and here is your 4 2 3 4. This is my A bar, B bar. So like this way you can write, and C bar here and C here. Okay, so here is your A bar B bar. So this is my 0. Here is what A bar B C bar. This is my 2, and this is what A bar B bar 1, 2, 3, 4, 5, 6, and 7. A B C bar, so it is 6, 7. Okay. Now what the requirement? Requirement is 3, 5, 6, 7. So which line will select which one? 3, 5, 6, 7. So 3 is here, 5 is here, 6, 7 is here. So it's obviously C and C bar. So it's 1. Um, it is 1. So here my C. Here is my C, and here is 0. So if this is my marks, this is select line A, B. Then obviously this is my 0, this is my C, and this is C, and this is my 1. So basically this is my I0, I1, I2, I3. This is my output. So just check the circuit. Okay, by 8 cross 1 mark. So I actually basically did, what I did, basically the I do it by 4 cross 1 multiplexer. So if 8 cross 1, then probably you need to choose more like something like this. Let's do it. 0, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. Okay. So this is my choosing I0, I1, I2, I3, I4, I5, I6, I7. So 3. Your 3 will be 1 here. 3. Again, output should be 3, 1, 3, 4, 6, 7, 3, 5, 6, 7. 3, 5, 6, 7. So here is 1, 3, 5, 6, 7. You can write this way. 3, 5, 6, 7. So 3 is 1, 5 is 1, 6 is 1, 7. So the marks using 4 cross 1, I also make the circuit how you can make. Here is 4 cross 1. So everything you can make the min term. Here is also 4 cross. And in the next lecture, I will upload demultiplexer. So here is my marks is say marks end, and next lecture I upload demultiplexer videos. Okay, so bye.